Today we'll be importing plies from FiberSim onto a mapped mesh. We'll begin by creating our simulation files. We'll also create a test solution, linear static, and we'll begin in the idealized part where we want to create a surface that's divided by the ply boundaries. So here you can see we have the plies being built up from the bottom in the Z direction. So what we'll do is we'll start with the bottom surface, and then we'll get some curves that we can use to divide up the faces by the ply boundaries. So here I'll use promote to get our bottom face sheet body. And here you can see there are a number of curves that are also on that bottom face. There are actually a number of duplicate curves, and what we want is a spline which forms a complete perimeter. So here we'll use some detail filtering in order to select just the splines. That will reduce the number of objects that come up in our quick pick. So you can see there are still multiple splines here as well, but using the quick pick we can get the ones with the complete perimeter. Here I've made a bad pick. You can use Shift mouse button 1 to deselect. Alright, now we have the same number on the other side. Now to facilitate map meshing, what we'll do is we'll put in some extra curves to help us divide up these small ply boundaries into map meshable regions. Alright, so now we'll go ahead and divide the face. And we can box select to get all of our curves. And then we can bring this into our FEM. Now one last check. We want to make sure that we're building up our plies from the bottom in the positive Z direction. In order to ensure that we're going to be building up our plies in that direction, we need to confirm that our surface normal is also in that same direction. And here you can see we can display the normal with the reverse normal command and hit cancel to not reverse it. If we hit OK, it would have reversed it. But we canceled out of the command, so the surface normal is going in the same direction as the Z-axis, which is correct. So we'll bring that sheet body into our FEM. With all of the ply divisions, and then we'll go ahead and create a 2D map mesh. And we'll start by mapping the interior, and we'll work our way out. And then lastly we'll put a shell mesh on the remaining face. We'll put all of these meshes into the same collector as well. Here I'll turn off the mesh control so we can better see the mesh, and that looks good. Alright, so let's go ahead and edit our collector to set it up for our laminate import. So here we'll create a new laminate physical property where we're inheriting from the layup. We'll pick our favorite ply failure theory and shear stress for bonding. Next we'll make sure that all of our material orientation vectors are consistent. Here you can see they're not. So let's go ahead and align them with the XC axis. This will help reduce the number of zones that are created after we import our plies from FiberSim. Next, we'll go ahead and load up the materials that we might need coming from the FiberSim import. Next, we'll go to the laminate toolbar where we can import our ply deck from FiberSim. If you don't have the laminate toolbar available, you can right-click to get it available. Then we'll go ahead and import to all of our faces, and we'll also select certain options for fill partially mapped faces and omit partially mapped faces to ensure that our import matches our boundaries. Here we're not going to import the material properties, even though we are importing the material names. It will automatically match up those materials that we've already loaded in the previous step. Here you can see we've imported 19 plies, and we can go ahead and update our global layups and zones, and this will create 11 zones. So here we can view our layup that we just imported. We can see things like the global ply ID, the composition, thickness, angle, as well as what faces the plies have been applied to. Another way we can view this is taking a look at the zones. Each zone has a consistent set of plies that make it up, and here you can see that subset of plies that apply to that specific zone. Alright, next we want to make sure that we're building our laminate up from the bottom, so we'll set that as our default for our layup offset. So it'll be starting from the bottom, working our way up in the positive Z direction as determined by our face normal, which then determines our element normal. Now here we'll try to take a look at our element thickness and offset, but it actually doesn't show because after making that change for our layup offset, we didn't update our global layups and zones. So let's go ahead and do that. And now we can go ahead and display the thickness and offset for our shell mesh. Alright, so you can see it's being built up from the bottom. You can see the thickness, different regions there, and how it steps up for those different ply boundaries. Alright, so that looks good. Let's go ahead and set up a test solve. So here we'll go ahead and put a constraint on the model. We'll go ahead and select all of the perimeter curves there. And we'll also put a G-load on the part. Alright, now we're ready to solve. And you can see this one runs in about 2 seconds. And we can see our results. And if we want, we can also animate them.